Hello, welcome and good evening to the next part of our Let's Code MS-DOS series. Last time we took a look at the VGA mode X, which gave us access to multiple video pages, and it was a bit hard to access those pixels, but the mode X is well worth it because it gives us access to the whole 256 kilobytes of RAM that the VGA has to offer. And today we want to look at further features that mode X allows us. So this was the memory layout, but this time we want to do scrolling, and we can do this by setting up virtual screens on the VGA. Before we had the mode running in 320 by 200 pixels, and while this is very nice, this allows us already to scroll vertically. You can have a look at my video about scrolling in text mode, which works exactly the same in mode X, even a little bit simpler, but scrolling horizontally is actually a bit more tricky. And for this very first video on scrolling, we will do a simple one. We will set up virtual screens, and we'll do them like here. We will have 4 different virtual screens because before we had 4 different video pages. Oh no, let's say it like this. There will be one virtual screen the size of 4 actual screens. All the actual screens are 320 by 200, and the whole screen will be 640 by 400. That 200 on the right should actually be a 400, so excuse that. And there will be a little bit of leftover at the bottom to make up for the 64 kilobyte segment or the 256 kilobytes. But we'll ignore that for now. For this current demo, we don't need that. The VGA can still only display 320 by 200 in this mode X or mode Y, to be more correct. And for example, we can put it to display this upper left corner. But we can actually tell the VGA to start at any space in this memory layout. So we can just increment it by and just move it around smoothly and in any direction with any animation that we want. Now, how do we do that? We actually only need one more thing that we haven't seen yet, and that is the offset register, which has index 13 in the CRT controller. And the offset register specifies the address difference between consecutive scan lines. That means one line that's on the monitor is being scanned, and when that's done, how much bytes are actually added to the pointer into the video memory. So usually it will say 320, or rather it will say 40, because we're using double word addressing in the chain 4 mode. And this has to be multiplied by 2 again, as this formula at the bottom says. Offset equals width divided by pixels per address times memory address size times 2. Pixels per address is 1 because we're using 8 bits per pixel, and the memory address size is 4, and that gives us 8. So 320 divided by 8 is 40. If we want to have 640 pixel wide virtual screen, we will put in the number 80. This gives us a 640 by 400 virtual screen that we can scroll on. So, having seen that, we're gonna put that in the background, and we can actually start coding. First of all, I would say we have a look at the main program. We will enhance it because we want to do animation. We will simply do the same trick that we did before in our text demos. We will compute some sine functions, one for the x direction and one for the y direction, so we get a nice animation. We can more or less copy this from the text demo, but I will just type it very quickly out for those that haven't watched. We need an iteration variable, and we go from 0 to 255. So, like this. And then the function for the x-coordinate, we will go between 0 and 320 pixels. This will be one full shift of the window. And we take the sine of 2 pi. Pi is already defined up here, times I divided over our step size, plus 1 to make it positive, divided by 2 to scale it back to 1. So this will give us a nice animation in the x direction. Let's do the same for the y direction. So sine y will be 200 lines of shift maximum, and we will make this a different speed, so we will use 128 as our scaling factor. This gives us more or less sine waves, basically. You can scale this up and down. You should do this by powers of 2, or at least by multiples of 256, so that you retain the cyclic nature of the sine function. Otherwise it will look weird. So this is already what we need. And then this time we will load 2 pictures, because at the moment we can still only load 320 by 200 pixels in size. We will change that eventually to access images that are larger than 1 segment, but that's more complicated. And already put in the copy to page routines, which we will give now virtual coordinates here, where to put it. So the first picture will go to 0, 0 offset, which is the top left corner of the first video page. Then this is the first video page. And then the second picture will go to 320, 0, which is the middle or the top right corner, not quite the top right corner, but the top right quadrant of the first video page. In this case, pages are still vertically, so not like the 4 quadrants that we have here, but I still define them in that fashion. Every scanline is part of only 1 page, so instead of 4 pages we only have 2 left in this mode. And we will need, after setting mode Y, we will need to actually set this virtual screen, so we will introduce a set virtual 640 function. This will set up the register and update the page offset so that they will work correctly. And then for the animation, we already got a frame counter. We won't use the page flipping, we don't need that. This will come back in a later episode when we do more fancy animation with scrolling. Okay, so we calculate the x-coordinate by just taking the frame counter and doing the modulo 256. And the same, of course, goes for the y-coordinate with the y sine function. Then we will introduce 2 new functions, set pan x, which takes the x-coordinate, and the same for the y-coordinate. Just like this. And then this will just calculate a few variables internally. And instead of the page flipping, we will have a function called update pan, which will update the panning synchronized with the vertical retrace, and do all the magic basically, and it will look similar to the page flipping function because it actually does very similar things. And this is already everything we need in the main program. However, the magic now still has to happen, and that will happen with the VGA module. Here we are. In the VGA module I already defined one new thing, and that is, did we already have the, I defined 2 things. I defined first of all the attribute controller addresses, which we will need to do more fine-grained scrolling, because I have to pull back a little bit, because as you know, we can update the start register of the CRTC to actually scroll, but we can, whenever we increment it by 1 in the mode X, it will actually go 4 pixels forward. So we can horizontally only scroll in 4 pixel increments. But we can use the attribute controller, it has a special register, to do single pixel shifts as well. That is a bit more difficult, but we will come to that in a minute. This is the register that we need for that. It's the so-called PAL panning register. Funny enough, it also has the index 13 hexadecimal, but this time in the attribute controller. And we also need the line offset register in the CRTC controller. The line offset register is described here, and you can of course also go to the pixel panning register. Let us see. Standard VGA chipset reference, VGA chipset reference, and then we want the attribute controller. Oh no, this is not complete. I wonder where I found this. Probably have to go. Sadly, this mirror is not complete. Yes, it definitely describes here how to access the attribute registers, but yeah, I just explain it when I come there. That's easier probably, because the attribute controller is different from all the other controllers. So let's go to the VGA module, and let's go to the set mode Y, and we will introduce the update page offset function. As usual, the first VGA page will stay the same. It will be always at offset 0. And the second one, and here we need to switch to double words actually, because we are now computing stuff that is probably bigger than 64 kilobytes. We take the current VGA width, which might be 640 now, times the current height, which will be 400, for example, or 200 actually for the pages. And I should write it correctly. Divide by 4 and be done with it, because we only have these 2 pages at the moment. We might do something more generic later on, but this will work for now. And then we need the set virtual 640 function. This will set up the virtual screen. So first of all, we do exactly update the VGA width variable that we need up there, and we will update the page offsets as seen, and this is also called at the start of the program. And then we need to write to the CRTC. So we do an output 1 byte to the index register, and we tell it, please write to the line offset register, very straightforward. And then to the CRTC data, we will write 80. We could have written VGA width divided by 4, and actually made this set virtual x and input some x here. But for now, we'll stick to this. Yeah, let's already prepare this. Maybe this is nice. Later we can then do arbitrary sizes, which is actually quite cool, I think. Okay, then we need to update the panning variables. So we will have a VGA pan x variable, and this will be the start address actually, and this is the wanted start address divided by 4 because that's how chain 4 works. And we need to store the pixel panning for the other register in the attribute controller, and this will be the remainder of this division so that we can actually get accurate pixel addresses. The Y panning is actually simpler because that's always accurate. We only need one variable for that. So VGA pan Y, and we should probably, it's a good idea to put a parameter here, int x, and one parameter int y. And this should do it. And I think, did I already introduce them? Yes. So the panning is a word, and the pixel panning is a byte because that's the size of the register. So that should be good enough. Yeah, pretty straightforward. And now we need to write the actual clever update pan routine, which updates the virtual screen address. So we will need the same stuff that we had in the page flipping. I will steal a lot from here. I already put in stuff here as well, but you will ignore that for now. You still know some older version, but maybe I won't copy that. Let's formulate it out. That's better, I think. So we definitely need to calculate an offset. I call this O, so it's a bit shorter to read. The offset is our Y panning, which is like, I don't know, something between 0 and 200 usually, or 0 and 199. And we'll take this times the current VGA width, which is 640. But again, this needs to be divided by 4, so we can either write divide by 4 or right shift by 2, plus whatever our current X panning is. This is the actual offset that we want to write. And that way we can again calculate the high and low address for the CRTC. And we'll do this in one go again. You can either do 2 byte writes or you can do 1 word write. And if you do the word write, then you have the constant for the register, and you OR that with the offset, and then you mask out the lower bit because the lower byte will contain the high address register number, and the upper byte will contain the upper byte of the offset, and the low address will be the low address register, and then not ANDing but just shifting, so the high byte will go away and the low byte will be in the high byte. Very simple. This is our stuff. We need to define this, so we will have a high address and a low address word. This is just fine. Next up, we need to write this. This will be done by an outport call without the B. So we write a word to the CRTC index register, high address, and then again the same for the low address. Now we already basically did everything we need. This will work, but it will look a bit jumpy in the X direction. We don't want that. So what do we do? First of all, we disable all interrupts because we're doing crazy stuff. We're disabling them, and never forget, enable them or your computer will hang and you can just simply reboot it. So the attribute controller is weird. That was the one I tried to show you, which I can't show you because it's not linked very well. It's weird because you write the... yeah, it's weird. First of all, you need to read the input status register. That's important because this will reset actually the attribute controller for reading. Then we need to read the data register and save it. Then we need to output the index that we want to write to. And then we will write it. And then we will restore the value that was in the attribute register, and we're done. And that's totally weird. So how do we do that? First of all, we need to input from the input status register, which we will do anyway for the syncing with the vertical read trace. But we will do that afterwards. So we read from the input status register and discard the value. We don't care about that. Then we will have to write the register that we want to manipulate. So we will output a byte. And that's actually, yeah, we will do that, and we tell it, please use the PAL panning register. But this will destroy the value that was in there before, so we will actually first have to read what is in the attribute controller. So we first read from this register, which is weird to say the least. And this will be a byte. And yeah, we will need to restore that. So at the end of the game, we will have to have something here doing AC write AC. If you don't do that, you will just see a black screen. You can try it, but this will destroy more or less the VGA. Not permanently, but temporarily at least. And otherwise it works actually quite the same as the other registers. After we write the PAL panning, we again write to the right register, and we write the actual value. So the VGA actually implements this by having a flip-flop behind this register. Every time you write, it toggles between taking an address of a register and taking the value. So here we do the following. We reset the flip-flop so that it's in the register index mode. Then we read the current register that is selected. Then we write our own register value, register index, and then after that the register value. And then we restore the register index as before. This is crazy important. You always have to do this, otherwise it won't work. But this is it. And now we can still, inside of the disabled interrupt, do our usual retrace, and this time I will copy it from below here, because it's always the same. You already know this. We did this a lot. And I shouldn't have moved the block, so I will copy it back down here, because I was too stupid. Okay. This is good. The set pixel is the same, apart from that we also do double word cast here, otherwise we get an overflow. But that is the only change, and I changed the copy to page routine to take a start address and a width and a height. But this only changes the set pixel routine so that it now has an offset that you can put in there, so that you could put the pixels anywhere you want on the virtual screen. Alright, I think this should be it. Let's try. There are a couple of errors. So we have forgotten to define a few things here. Int or word, I don't know, doesn't matter. Let's say word x and y. And also frame. 3 warnings, 3 errors. Okay, Yes. Possible use of frame. We should initialize it, right? 3 errors. Redeclaration of update page offsets. Oh. Okay. Yeah, there are a couple of... okay, I renamed those things. VGA X pen and VGA Y pen. That's fine. Wrong variable names can happen to the best. Of course. Update page offsets. Did I already write that function? Oh yes, okay, I kept it in there. Yeah, let's kick one of them out. I, of course, tried the code first and then deleted it again, but not this part. Still one error. Type mismatch. Okay. Why? Why is there a type mismatch? Okay. C, VGA C. Oh yeah, of course. Because it was implicitly declared, I need to move it to the top. I need to move it pretty much to the top, at least above the set mode Y. This is a peculiarity of ANSI C, because I also use it when I set the actual mode. When C sees the function and it hasn't been declared yet, it will assume that the function returns int. But of course this is a void function, so there was a type mismatch. I can do a separate episode about peculiarities on C if you want. Just leave something in the comments. And shall we try to run it? It's loading 2 images. And there's something broken. Okay, this shouldn't look like that. So there's something rotten. Well, it looks roughly correct. And it's scrolling. Very nice. But there is something off. We did some oopsie here. So the picture is actually squished, and at the bottom you can see a bit of garbage that the image wraps around. Question is, what did we do? Did we do something wrong here? Oh yes, oh yes. It should have been 8. That's why the whole thing wraps around. Let's try this again. So I think our virtual screen was actually too large. Yeah, this looks much better. So we'll see the picture still twice, because I did a 640 by 200 picture. You could have used a 640 by 400 picture, which would have made more sense, but at the beginning I just wanted to do horizontal scrolling, and then I realized actually we can do both at the same time. So yeah, that's what we wanted to see actually, and we will just quickly try it on the 386 as well, shall we, to see that it actually runs on real hardware. Okay, here we are on the 386, and yeah, let's run the program. And it is roughly the same speed as the DOSBox emulator, same cycles, but copying the images to video RAM is still a bit slow. We will visit that in a later episode, how to do fast copies. And as you can see, it also works on a real machine. The capture of course isn't perfect. If you watch this on a real monitor, then it will be very smooth indeed. The capture card, my cheap capture card, is really struggling. I'm capturing with 60 frames per second, but I only get like 49 to 53 frames per second at the moment. But still, it shows that it actually works, and I hope you don't get dizzy. Anyway, that about wraps it up for today. I hope you learned something. Please feel free to ask questions and put some comments down below. What do you want to see next? Are there other topics that interest you? I have quite a bit planned, because we are not quite progressing with the game that I want to write, but we have most of the stuff in place. We need a bit more fast copying routines for animating stuff, but that will come. Other than that, make sure that you subscribe, hit the like button and share this video if you want. And there's always also the chance to support me on Patreon and on Ko-fi to buy me a coffee. That will be greatly appreciated. And if you can't do that or don't want to do that, it's no big deal either. So I hope to see you next time. In the meantime, see you until then.